Hi, this is our project on food versus fuel, biofuel production.
So, what are biofuels? Biofuels are when organic material is converted into usable fuel such as ethanol or biodiesel. Biofuel organic material is constantly evolving and has multiple generations of development. First generation biofuels are directly from food crops, secondary biofuels are made from non-food crops, and third generation biofuels are derived from marine biomass. Second and third generation biofuels are a great way to reduce harm by using up unwanted byproducts for energy. On the other hand, growing crops simply for the purpose of using them for fuel is controversial, given that large-scale crop production typically results in lower plant diversity and overall environmental harm.
Why are biofuels important? Biofuels are able to replace fossil fuels and other non-renewable energy sources, contributing to a growing number of fuel alternatives. In addition, biofuels help combat climate change through lower greenhouse gas emissions, since it takes in a lot of waste product and converts it into a usable energy source. Biofuel also contributes to society by providing economic benefits like job creation from building plants and increased energy security by providing a renewable energy source that is not dependent on environmental conditions, such as wind and solar. This means that it can be used anywhere and does not have to rely on the region's climate to operate. While biofuels are generally a good renewable source of energy, there is still a major debate about biofuels, about the argument between crops for fuel versus crops for food. As the demand for biofuels increases, food crops may be diverted towards fuel production, potentially raising food prices and increasing land use.
Next, let's take a look at our system map. In our system map, we outline factors from each different category, including societal, environmental, and technical components. The goal of this analysis is to understand how these components interact to influence the development and viability of biofuels. An interesting negative feedback loop is that the increase in amount of carbon emissions increases the government funding for biofuel research, which increases the number of researchers looking into biofuel production, which then increases the sustainability of biofuel production, which ultimately decreases the amount of carbon emissions. This loop shows how the environmental and societal factors are linked together in the development of biofuel as a sustainable form of energy.
Our problem focused on a biofuel plant. We introduced the chemical equation for the biofuel combustion process and analyzed a detailed table of thermodynamic properties, as shown. These values are essential because they allow us to quantify how much energy the plant produces and how efficient it is. Using the given information, we wanted to know the standard enthalpy change and determine whether it was an endo- or exothermic reaction. We determined that an exothermic reaction is ideal for a biofuel plant because it means the fuel releases energy when burned. The challenge isn't that it's exothermic, it's that the energy release is efficient and comparable to conventional fuels. However, we are aware that a highly exothermic reaction comes with its drawbacks, since additional energy would need to be expended to keep the reaction plant cool to facilitate a continual prioritization of the forward reaction. Also, using given values, we wanted to estimate the heat released per hour. This tells us how much power the plant can actually generate, which is essential when comparing biofuels to other energy sources.
Moving on, talking about the impact of producing biofuels, there are potential trade-offs between producing food and producing fuel. For example, large amounts of ethanol produced may lead to air pollution. In addition to that, an increase in biofuel production increases incentive to produce more corn, but also decreases the biodiversity of crops farmed. We also can produce cheaper, more sustainable fuel, and an increase in biofuel production can introduce more job opportunities. To conclude, we summarized the thermodynamic solution. We calculated the enthalpy change, confirmed that it's exothermic, and estimated the overall heat production of the system. These numerical results give us a clearer picture of our plant's energy output and efficiency. From a broader perspective, biofuels can serve as one alternative in the transition away from fossil fuels, but they should not be relied upon as the sole replacement, especially when they compete with food production. Our impact analysis shows that using crops for fuel introduces real concerns about land use, food availability, and environmental sustainability. Looking ahead, biofuels may move toward non-food feedstocks such as algae and agricultural waste, which could reduce pressure on food systems while still providing renewable energy.
Here are our references. Thanks for listening.